Let's get started with 6 radian measure and their applications. So what is a radian? A radian is just another way to measure the size of an angle. And so just like with temperature, we have Fahrenheit and we have Celsius. For an angle, we've got degrees, which we've used quite a bit. And now we're going to introduce unit of a radian. So the definition of a radian: 1 radian is the angle measured out when the radius is the same as the arc length. All right, so if we look at that, we're going to say that theta in radians here is equal to the arc length divided by the radius. Okay, so that'll be our first definition for radian measure. So let's find the radian measure given a couple things. This is fairly straightforward. So theta equals S over R. If the arc length is 4 feet, oh, by the way, S, that's the variable we're always going to use for the arc length. And so that's the distance on the edge of the circle walking around. All right, so in this case, they tell us the arc length is 4 feet and the radius is 10 feet. Feet and feet will cancel out, and we're left with 0.4 radians. All right, I would say give it a shot, but I'm pretty sure you can divide 3 by 50. So in this case, theta is 3 over 50, or 0.06 radians. All right, so there's another example here. We're going to skip that. I think you guys can all divide. Let's move on and see how we can convert from degrees to radians. So the full circle, if you spun all the way around the circle, we know that that's 360 degrees. And that is also equal to 2 times pi radians. So the matchup here is if we divided both by 2, we would get pi matching up with 180 degrees. So that's the ratio you'd use to convert from one to the other. So let's try one. Let's convert 45 degrees to radians. So our job here is to cancel out the degrees. So we need to multiply it by some fraction where degrees is in the denominator. We know that the constant is 180. That matches up with pi radians. The degrees cancel out, and so we'd have 45 pi over 180 radians. And 45 goes into 180 4 times, so we would have pi over 4 radians as our answer. Give it a shot. Okay, hopefully you said 60 times pi over 180. Ended up with pi over 3 radians. Okay, we can do it again with something not as easy of a number, 472 times, again, pi over 180. And so we would end up with 472 pi over 180. The degrees would cancel out. And so now let's reduce this. So 472, 4 goes into that. That's 118. And 180 divided by 4 is 45. And I believe, does 3 go into both of those? No. Let's see what else. 9 and 5. 9 doesn't go in, and neither does 5, so that is reduced. 118 pi over 45. Okay. All right, so give that a shot. 460 degrees, turn to radians. Correct answer, 460 degrees times pi over 180. Cancel out the degrees and the 0, so we'd have 46 pi over 18. Those are both even, so 23 pi over 9 radians. Okay, let's go the other direction. 2 pi over 3, 2 degrees. So we're going to multiply this. We're going to flip that fraction over, 180 degrees over pi. Pi's cancel. We'd have 180 divided by 3 is 60, so 2 times 60 is 120 degrees. Give it a shot. Okay, 3 pi over 2. You're going to times by 180 degrees over pi. Cancel your pi's. 180 divided by 2 is 90. 3 times 90 is 270 degrees. Okay, so we looked at the unit chart last chapter. Just a reminder, this is what we've got going here. We can, not last chapter, last class. 30, 45, and 60 are our important angles. 30 matches up with pi over 6. 45 is pi over 4, and 60 is pi over 3. And then lastly, the quadrantal angle of 90 is pi over 2. If you know those four, you can count yourself all the way around the unit circle. Okay, so let's figure out some formulas that we're going to use with our radians. So we started out by saying that theta equals S over R. If we multiply both sides by R, we end up with this formula, S equals R theta. Now, all these formulas need to be in radians. If your theta is given in degrees, you need to multiply by pi over 180, get it back into radians for all these formulas to work. All right, let's solve for an arc length. So in a circle with a radius of 10 centimeters, the arc is intercepted by a central angle with 7 pi over 4 radians. So S equals R theta. So that is going to equal 10 times 7 pi over 4. So we've got 70. Let's just reduce this first. That's a 2 and that's a 5. So we'd have 35 pi over 2 radians. Okay? And that's in, sorry, not radians. What's our unit? Centimeters would be our unit because this is an arc length. Okay? It did not state around, so we'll leave it as an exact answer. Your turn. So S equals 15 times pi over 3. So that's 5 pi, and our unit, inches. So we got to be using units for all of these problems. Okay, the International Space Station, 400 kilometers above the surface of the Earth. If the ground station tracks the space station when it has within a 45-degree central angle, so within 45 degrees in here, then how many kilometers does the International Space Station cover while it is being tracked? So what is this distance? That is an arc length, so we're going to solve for that. S equals R theta. So we know theta is 45, but what's the radius? So we got to say 6,400 plus the extra 400. So this would be 6,800. And then we're going to say times the angle is 45 degrees, but we do need to turn that into radians. So we'll say times pi over 180, and this would be pi over 4. So let's plug it into our calculators. We would say 6,800 divided by 4 is 1,700. So the arc length is 1,700 times pi. But it does say round to the nearest kilometer, so let's do 1,700 times pi. We'd get 5,341. All right, give it a shot. Okay, so S equals R theta again. That's 6,800 for our radius again. And your theta is going to be 60 pi over 180, or pi over 3. So 6,800 times pi divided by 3, I get 7121 kilometers. Again, we're always putting the units. I think I might have not done that back here. Kilometers. Okay, what about the area of a sector of a circle? So we know that the area of a whole circle is pi r squared. But what about just a slice of a circle? That's going to be given as 1/2 r squared theta. 1/2 r squared theta, again in radians. So let's give this a shot. Find the area of the sector. So area equals 1/2 r squared theta is our formula. Single slice of pizza if the entire pizza has a 14-inch diameter. So be careful here. 1/2 7 squared. The pizza is cut into 8 equal pieces. Okay, so we want to know about one slice. And so if we're cut into 8 equal pieces, we know that an entire circle has 2 pi radians. So let's cut that by 8. So we would say pi over 4 is our theta. All right, so we're going to say 0.5 times 49 and divided by 4. I get 6.125. So let's actually do this better. 49 pi over 8, because it does not say to round here. 49 pi over 8. And what's our unit here? You said inches squared. You are correct, because our radius was in inches, and then we squared it. Your turn. All right, almost the same problem. A equals 1/2 squared this time. And we're also going to say pi over 4. So we're going to say 64 pi over 8. turns into 8 pi, and again, inches squared. Okay, let's find the area of a sector when the angle has a degree measure. So the sprinkler comes on. The sprinkler sprays in a 90-degree angle. 90 degrees, we're going to immediately times it by pi over 180. So we're going to say pi over 2 instead of 90 degrees. All right, and it has enough pressure to keep a constant 25-foot spray. So we're going to say the area is 1/2 r squared times the angle, pi over 2, round to the nearest square foot. So let's plug this into our calculator. 0.5 times 25 squared times pi divided by 2 is 491 square feet. Your turn. All right, the sprinkler head rotates 180 degrees. That is pi. 180 matches up with pi. So we're going to say the area is 1/2. It's a 30-foot spray, so 30 squared times pi. And what do we have here? So we're going to have 450 times pi. And we get 1,414 square feet. All right, linear speed. Let's talk about speed. We got a couple formulas for speed. Speed is defined as distance covered over time. If we're talking about linear speed or velocity, that's going to be moving along the edge of a circle. So how much do we cover? How much ground do we cover on the edge of the circle divided by time? So S for our arc length divided by time. B equals S over T. All right, so a car travels at a constant speed around a circular track. The circumference is 2 miles. So the distance all the way around here is 2 miles. We'll go for 9 laps. All right, so how far did we actually go? The S here is going to be a distance of 18 miles. All right, we've traveled 18 miles if we went 2 miles each lap, and we went for 9 laps. Our time is 15 minutes. So that would be our velocity, our linear speed. But it does say we want this in miles per hour. So we're going to do a quick unit analysis. There are 60 minutes in 1 hour. And so now let's multiply this across. 18 times 60 divided by 15. And you get 72 miles per hour. Your turn. Okay, V equals your S. The circumference is 3, and we do 7 laps, so 21 miles in a time of 12 minutes. And again, we wanted this in miles per hour, not minutes, so 60 minutes over 1 hour. 21 times 60 divided by 12, we get 105 miles per hour. All right, angular speed. This is how fast you are rotating, not how fast you are moving in a straight line. So if you have an old vinyl record player, you'll know that they come in RPMs or revolutions per minute. That's an example of angular speed. So we use omega for our variable. That's equal to how many radians we've covered, right? The angle that we've covered divided by time. Okay, so a lighthouse in the middle of a channel rotates its light in a circular motion with constant speed. The beacon of light completes 1 rotation every 10 seconds. I'll be done in just a minute. But do you need to print something? No. If we want this in radians per minute, I'm just recording a video. We're going to say there are 60 seconds in 1 minute. And there are 2 pi radians in 1 rotation. Cancel, cancel, and cancel, cancel. And so we'll have 120 pi over 10. And so we'll say 12 pi. And we have radians per minute. Your turn. Okay, so we're going to say omega equals 1 rotation every 40 seconds. And so we'll convert this into radians per minute. So we get 2 pi radians per 1 rotation, and we get 60 seconds in 1 minute. So we'll end up with 120 pi over 40, which reduces down to 3 pi radians per minute. All right, last example, example 12. We're going to do this in class next time I see you. So we are done with the video for now. Any questions? I will see you next time.